Thank you very much. Thank you all for attending the talk today. This talk will report about you on projects that we are developing. I am a visiting professor here, not far from here, from Karlsruhe at Heidelberg University, Department of Geography, and I'm also a faculty in Brazil at the University of São Paulo. And we have been working into this disaster management area and into how to use the OpenStreetMap to improve the practices of disaster managers. And this is the research that I will talk to you about. Well, to give you some initial motivation, as you all know, OSM has been used in the context of disasters since quite some time, and many of you know these maps of Haiti 2010 before and after, which are mirrored again in a more recent experience last year with the typhoon in the Philippines. We also had an incredible mapping activity that was directed towards completing this map. We also were part of this into some different mapathons that we organized in Heidelberg and so on. And we came down to the question for the research to deal with is also since quite some time. The University of Heidelberg was involved, for example, in Haiti and putting up a service for emergency routing based on the tagging of OSM, so avoiding blocked roads and using this to do routing decisions. And this was a portal that was done for the University of Heidelberg in this context as well. And well, with this background in mind, we already see that OSM has a big potential in the field of disaster management. It's already used today. So we came to the question here, how can this potential of OSM be leveraged to support also risk analysis and emergency planning? That is, mostly today, OSM is used after to respond to disasters, and it has been also uptaken by humanitarian agencies and organizations to be used. And we would like then to make the data of OSM more useful also for the phases before the disaster strikes, which are so-called preparedness phases. And this is why we posed this research question here, to examine how can we then try to use and improve the quality of OSM in this context, to this particular use of risk analysis and emergency planning, as we know is an important challenge of our society today. So for this project, our goals were then developing an approach to identify what we call elements at risk based on literature, using OSM as a volunteer geographic information source. So elements at risk are those critical elements that we have to take care when doing, for example, emergency planning, where the assets that we have to protect first, so to say. So this was the first goal, is how can we identify these elements at risk from OSM. And then what we envision is the development of a toolbox for the automated extraction of this kind of information from OSM to subsidize, to be a resource for emergency planners and risk analysis. And on the other hand, we would like also, as a more scientific and community contribution, to evaluate the quality of OpenStreetMap for this particular use. Well, it's sometimes called in the literature fitness for use kind of quality evaluation. So with this in mind, we approached this concept of elements at risk, taking the particular scenario of floods. So in floods, and in general, we have this definition of risk as the total amount of elements at risk and composed by the hazard and the vulnerability of the system. So these three components of risk, we would like to extract from OSM the first component and then have from the other ones from official data in order to compare. So here you can see a pictorial representation that helps us to illustrate this concept. First you have hazards, and hazards are mostly, in the case of floods, represented by so-called hazard maps, which represent areas with different probability of floods to happen. For example, here, the darkest ones are the areas in which you have a probability of floods in each 10 years. And as you go more, as you have other colors here, you have different probabilities, for example, a 100-year flood and a 50-year flood. So this is the hazard maps that we become from experts, from different methodologies of hydrologists that put up this kind of hazard maps. And then what we would like to do is then to identify these exposed elements, the exposed elements that we are calling elements at risk here. For example, fire stations, schools, hospitals, such critical objects that you must take care of in the first place when a disaster strikes. And by examining here spatially how these objects are located into the different hazard areas, you can then compose both, in the concept of vulnerability. That is, then you can see, for example, that you have a critical object here, which is in a region that is very threatened by floods. Then you have to take care of this object more carefully, or you have to plan for it and account for it. So this was, so to say, the conceptual basis of our work here. And in this picture here, I will explain you a little bit of the workflow we developed from extract this information from OSM. We start here in the first place by drawing some categories of those elements at risk. Well, what are the kinds of elements at risk that we have to take care? And in the first place, we used a framework developed by FEMA, by the Federal Emergency Agency from the United States, called HAZUS. And they defined different categories that I don't know if you in the back can read, but it's like essential facilities, high potential loss facilities, utility systems, transportation systems, general building stock, hazardous material facilities, and here demographics. And these are so-called categories of elements at risk. And these were used then as a basis for we to approach the OSM databases and see what can we from this kind of categories extract from OSM or gain from OSM. And then for these we took the OSM database here and did an initial mapping of the tags, of the existing tags of objects in OSM, comparing to these categories of HAZUS. And then we extracted these tags, for example, amenity fire station, amenity school, and amenity hospital. And this was this correspondence between these two worlds, between the world of the disaster and risk planners on the one hand, and the other, the OSM way of categorizing objects. And then we applied this into a specific use case, which is the city of Cologne in Germany, to extract the data based on the official hazard map. So we got the official hazard map from the city of Cologne, and then extracted here the different elements that were in the different hazard zones. So the results is like we generated a data model, initial data model that we will also propose to the community and hope to get also the contribution of others, which tries to do this kind of mapping between these concepts of hazards like essential facilities and the different OSM keys and values and that correspond to this. For example, we detected for essential facilities 25 OSM tags, which we found relevant for this kind of analysis that you can see, maybe you can see here. I will not go over all of them, but you already can have a glimpse that actually you have pretty good information and also pretty complete information in terms of what is possible in the OSM database. And then from the analysis of the case study in this pilot application in Cologne, we detected, identifying that 12 of the tags were used by the mappers. Well, of these 25 that we initially chosen, actually in the practice, 12 of them are currently used in the OSM map of Cologne, right? And in this led us to 168 objects identified for this category of essential facilities. And here you can see this pictorial representation, the hazard map with the different colors here, meaning the different hazard zones or the probabilities of flood, and the different types of elements at risk here that we found. So 168. So this was an initial result, well, already very promising, and we are also in contact with stakeholders from the flood management department of Cologne in order to validate this. Well, our idea is that we get from them what we got already, the data about what they consider their essential assets, their elements at risk, and then we will compare to Cologne and then check the match, or in what extent OSM has more use or more updated information, for example, or also missing information in comparison to the official data they have in present. So then going now to the future work, what we would like or what we envisage with this approach is to build a framework for evaluating quality for this particular use of risk analysis and emergency planning. In OSM, our idea is then to develop a quality framework that is capable of evaluating the data of a region and then serving as a basis for the decision of the stakeholders, of the risk planners, for example, can I use the basis or not, based on different indicators, quality indicators. So, for example, this analysis that I already showed you, but also other more indicators related to positional accuracy and other kinds of data, or completeness of the data and so on. And so we can have a kind of scale or a kind of index of quality that can support the decision of these stakeholders in doing emergency planning targeted at this preparedness phase, right? So the use cases we are envisaging are emergency response and more broadly risk assessment, including this. And the other very important thing for us is actually how do we engage the community. So an important part of our work here is how can we qualify these different objects for risk mapping through extended tagging. Well, one thing that we think would be a very important use of our model is as long as we define this basic categories or these important objects that you can see that are useful for risk planning and emergency response, this can also serve as an orientation guide for the mappers, so that you can see, okay, these are the objects that are very important and we should map first, or we should care about them. And also, this can go beyond only the identification of object, but also going through the characteristics of objects. So one thing we are already discussing is for example, different tags for characteristics that are important for hazard research. For example, if a building has an elevated floor, this is an important information to measure the vulnerability of this building against floods. right? The same thing is being done in other projects for earthquakes, for example, defining the materials of the building and then tagging these types of materials. And then, of course, they will have different vulnerability levels based on the type of material that is used for the building. And this is exactly what we would like to envisage here. So to complete this data model, and this data model could serve both the practitioners or the risk planners in the sense that we could then use the information for the risk analysis and emergency planning, and the community, because then the OSM community could use this as orientation to guide mapping efforts so that these mapping efforts can also be beneficial in a crisis event, for example, in a flood event. And this is what we are calling map your environment through the lens of a crisis manager. So that you see that, well, we have to map an object, what kind of information of this object, of this building, etc., is of particular value for a crisis manager. For example, in this case that I was referring previously. And the other thing that we envisage as important case here is that we can, in this sense, build local mapping communities, OSM mapping communities, to foster this kind of interaction between stakeholders and local planners and the OSM community, so that we can also, of course, specialize this model that we are proposing, which is supposed to be a general model, to more specific case. So we are now approaching, initiating a project, for example, that is targeted here in Germany with a partner city to narrow down this model for this specific reality of planning for floods in Germany. But the hope or the expectation is that this can also be used as a basis for this model to be adapted to other contexts and other necessities. And as I am from Brazil as well, so I'm very interested, for example, in Brazil, that we don't have such a quality of OSM, that we can also use this as a basis for stimulating the local OSM community in Brazil to produce this kind of information, which is very, very valuable. And maybe more valuable than here in Germany, because in Germany you have more data in general that we have, for example, in developing countries like like Brazil, and in many parts of Brazil this is an issue. And one question that is like a very important one that is not solved, but we have to deal with, is privacy issues. So especially here in Germany, where people are very privacy aware, so to say, right? There is a awareness about privacy, and privacy concerns are very present. So with this more specific type of tagging objects, like, for example, elevated floor, the state of the building or the age of the building or something like this, if you start to map this systematically, this may raise privacy concerns from people that have their houses mapped, and this can be, for example, used also by insurance companies or for other purposes. So this is, of course, one thing we have to balance or to take care and to see how can we deal with it. So to conclude the talk and invite your questions and contributions pretty much, we would like just to summarize our thoughts here, that we are then developing this approach that can be used for providing this quick identification and assessment of critical objects in risk areas. And we have to further refine the data in the model here, and we also ask for your contribution on this. And but what we already see is that the OSM data model already contains most of the important object types for emergency planning and risk analysis, and this is good news. So, and of course, since there is a lively community behind the data, the potential to improve this towards making the data even more adapted to this kind of analysis I understand that this is a very important potential. And our future analysis, as I mentioned briefly, should assess the quality of OSM data towards this particular goal, this fitness for use, and we propose that this kind of assessment will be an important decision support instrument for stakeholders. So with this, I will leave up to that. Thank you very much for your attention and inviting your questions.
Thank you, João. Does anybody have any questions while we set up the next talk?
Hi, how do you plan to amend your flooding calculations given climate change?
I'm sorry, I didn't hear you very well. How do I plan
How are you planning to change your hazard calculations based on climate change?
Oh, very good point. Well, actually, this is a big issue even in the hazard, let's say, scientific community about natural hazards, right? Because the thing is, most of these calculations are based on current scenarios, and as we see with climate change, these scenarios are expected to change dramatically or change in a very short time. So I understand we would like to aim for a dynamic adaptation, or for a tool that allows, for example, the to update the models, so that as soon as you have updated the hazard models, you could input them into the systems and recalculate your objects of elements at risk. So thank you for the question. This is a very important issue that must be addressed, the dynamics of the hazard models behind, right?
So I have a question that, so how much information do you think that you can extract from images, geotag images, to identify the risk elements from images?
You are referring to images in other kinds of platforms like social media platforms, or?
So, for example, if you have recorded a sequence of geotag images when you try to collect the OSM data, for example, so how do you think you can extract information from those images? So give you a cell phone, and then the cell phone have GPS and also compass direction, and you go out and collect OSM data. In the meantime, you collect photos. So how much information you can extract for this project?
Very good question. Well, I think this is an important way to go, because actually the information that you can get from aerial images in our experience is very limited. So if you can complement with in situ observations and pictures made at the local, this will offer many opportunities. For example, information about the elevation of buildings that I already told you, materials of buildings, and such kinds of things are very specific, and they cannot be seen from aerial images that we use today for doing remote mapping or so. So this kind of local observations with photos would be very, very valuable for this. Yeah, definitely. Thank you.
I have one question regarding the tagging scheme. Do you need any additional taggings? Or if I, as a mapper, see this as some valuable project I could start to work on, is there some point I could look up some tags or a wiki page or something like that?
Very good point, thank you. Actually, we are putting this theme, well, after this talk here, we are putting this into a wiki, and we'll send into the list for the community for contributions, because we expect also the contributions of the community as well. And this is exactly our idea, that we will release the data model also to get your contributions, and that you can use as well for your mapping efforts. This is exactly what we foresee.
Okay, so in that case, thanks once again for an excellent talk. And yes, do we have Francesca to prepare?
Thank you.